You're listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and this is the podcast where you're going to get expert advice about the heavy duty parts that you buy and keep informed about what's going on in the industry. This episode is sponsored by TruckPartsCross.com. With over 1.5 million crosses and counting, every day that number just keeps growing. You can cross about any part you're looking for on TruckPartsCross.com. Diesel engines have been transformed by technology over the last 20 years. Now electric-powered trucks are being mass-produced by companies like Nikola Motor Company and the other traditional truck manufacturers. Things sure are changing. What will the development of all this technology mean for parts and heavy-duty repair technicians in the future? To help us with that, I'd like to introduce to you Craig Barnes, president of Cab Consulting. Craig recently concluded a 31-year career with Cummins, and after retiring, he started his own consulting business to support the heavy-duty trucking industry. Craig, welcome to the podcast.
Thank you, Jamie.
Craig, I had a question for you. When you started with Cummins, everything when it came to diesel engines was mechanical. You know, that old expression gearhead kind of came from that mechanical nature of diesel engines. What technology started to change diesel engines? Let's go back in time a little bit and talk about that.
Okay. Well, I think around the late 80s and early 90s, you began to have this thing called electronics. And that became, it kind of got into fuel systems a little bit. And then, it got into where you could adjust cam timing a little bit and a few other variables. And so it sort of drove the industry to, at that time, called what we called smart vehicles. And you could now do things that like a traditional fuel pump, it's a mechanical device, and you could have so much fuel at idle. Then you get so much fuel at rated, and then it was a mechanical device. So what you got in between is what you got.
I'm really curious about that. So as this electronics started to come into the way that diesel engines operated, did that make it so that there was more horsepower, there was more efficiency? What impact did it have on trucking fleets in the real world?
Well, it sort of touched everything, because now with electronics, you could do things at speeds and loads that you couldn't do before. You could adjust when fuel goes in, and then probably one of the major innovations that came in was a common rail fuel system. Right now, it allows you to have pressure independent of engine speed. Okay, now I have pressure independent of engine speed, and I have electronic controls that can tell me when and where to put it in. So the noisy diesel began to disappear, because now I could have a pilot injection. Put just a little bit of fuel in and make that direct injection. So that was a big invention that you sort of saw indirect injections go away as they could make that quieter and better. It helps you on emissions, because you could now better operate, in what we call the NOx zones or the PM zones on the maps, and you could optimize that about how it was used. And then also, as the standards got tougher, the old 2-cycle, the Jimmy diesels, all of those from Detroit, and they kind of went by the wayside because they couldn't meet things. So you could now play with, power density. You can now have torque at very low speeds, that you didn't have before. So it touched about every area. Probably came into the trucking first, and then it moved into, other fields.
Right, because it affected industrial and agricultural. It wasn't just, like you say, just trucks.
Right. It started there that's a big piece that probably made diesel engines and pickup trucks very popular.
Oh, of course. Yeah. The automotive sector as well. So when you were working at Cummins and this technology was starting to become prolific and it was really changing the way trucks were operating, was there any things that you guys ran into that were real head scratchers? You had some real problems? I'd love to hear a story from back in the day of how this developed, or maybe the other side of it where things just went way better than you expected.
Well, in the early days, the biggest thing about it was, it had to have a reference signal. So, you had to have a flywheel and then a signal off a cam or something, so that when you knew where you were. And you really couldn't do what we traditionally today now call a Control-Alt-Delete. You couldn't reset yourself going down in the middle of the road. So you had to try to develop sensors and then make sure that the timing always stayed. And in the old days, I grew up in a rural area, and one of the things with tractors, is we tinked with the pump. You'd buy it at 185 horsepower and get 230 out of it. Well, you couldn't quite do those things now because that would make the engine get lost. And so there was a lot of learning about that, of how you did it. And I would say what went wrong with some of it there was, if you recall, in the late 90s, there was the EPA came down on the diesel industry and accused everyone of cheating, because now that the engine was smart, I could also know where I was. And so they said, well, you're not meeting the emission standards. And so that drove being very good at what we did actually ended up people saying, no, you're cheating, when we really weren't, and drove you into having emission standards come on much more stringent, much faster than they were before. So, being really smart and having all that was really good. We knew what we could do, but there were others who interpreted things a little bit differently. So it took a while and sort of set us down a path that it gives you the engine you have today.
When it comes to the emission controls, it's kind of interesting when you talk to different people, because you get a real sense of where their perceptions are. I kind of see like two polarizing groups kind of have emerged in the trucking industry over the last 10, 15 years, especially as emission control and climate change and all of that has become such a dynamic and hot topic in politics. It's funny because I see some people who are like playing the Greta Thunberg little audio clips, and they're playing it over a video of them belching out black smoke out of their diesel truck. And then you have other people who kind of have this opinion that, the government's had to come in and really crunch down on the trucking industry because these manufacturers just weren't responding. What was the actual climate, at a company like Cummins over that time period where the emission control standards were changing? What were they talking about? What was their attitude towards it? I just can't see them being these evil people like, wahaha, let's screw up the world's environment with our diesel engines.
No, it really wasn't that way. I mean, even as they've developed all the standards going forward, we were actually right beside the government, helping them develop them, writing reports and guiding them. And we felt that it was an advantage that the more stringent you made the emission standards, the better engineers we could become in that. There were, we thought many times there's a physical limit as to what we can do. You can only get so much out of the engine and that's it. And that drove the world to invent after treatment devices. That technology evolved. Well, yeah, that causes a lot of problems, and they got better. And now, if you see a black belch of smoke come out of a truck that has all the new equipment on it, there's something a lot worse wrong than just somebody played with the engine. And the nitrous oxides, we got those out, and that actually turned into a benefit for fuel economy. So the greenhouse gas regulations actually turned into an improvement that the consumer would see, because if you have better fuel economy, you reduce the greenhouse gases you're putting out. So it actually, as you develop those, it became a better and better product, and it forced the industry to make some bets. Some companies' bets worked and some didn't real well, and those that did it right went in, and then the rest of the world, we've worked. I worked personally in India and China a lot on taking them to the next emission levels, and I think come this spring, India will be at almost the equivalent of what the U.S. regulations are. China is there, and Europe's driven a lot. So it's been one of those that it's been working with them. They're not the enemy. We always used to say, the chief technical officer of Cummins at the time I worked for him, Dr. John Wall, he said, the EPA helps set the regulations that, it's the table stakes to be able to play the game. He said, but we got to remember they've never bought an engine yet. So the customers do. So you have the regulations, just meeting them was just table stakes. How well you did after that was how you were able to compete and play and stay in business.
Now, when those changes were coming into effect, it did push technicians to learn new skills, to have to take on maybe a little bit of additional training, especially if they were coming from the really old school and getting into electronics. What was the kind of the impact on, parts technicians and heavy duty repair technicians back then? Like, how much did it actually force them to change or learn new things?
if you've been around them a while and tinkered, and I have too, you used to be able to take a screwdriver and adjust the belt, you did everything kind of mechanically, and your ear could listen to it, and you knew that over your years' experience, well, if I do this, this will happen going on. With electronics, all of a sudden now that didn't work, and in fact, what used to work made it worse. And so what you really had to be able to do was use service tools, which used to be the thing that you never wanted to take it off the bench. I've worked with a lot of guys in the ag industry and others is, no, I can take care of it. No, you really do have to plug this tool into the engine and find out exactly what it's telling you and give you the diagnostics of what's going on. And with after treatment devices, there's a lot of fault codes and some of them are pretty sophisticated because to continue to meet the regulations and all the requirements they have. So I would say the biggest thing is not that they had to be computer literate, but they had to be able to use the tools and be willing to sort of follow the directions that said, well, go down this path. Like you're talking rabbit holes, head down this way, or here's the 4 possibilities of what it might be and how you check it out. So it's sort of changed that portion versus you coming in and say, I've got a noise and okay, I'll go look at it. Is it now I bring it in, I need to look at it, and okay, they'll plug it in and they'll say, well, here's what it says.
So now we move kind of to the more recent times, so the last couple years, really big data and the ability to be connected at a much higher level than ever before is really what's driving kind of the next phase of technological development on engines and on diesel trucks as a rule. Is that the way you see it as well? As that being the next kind of big jump?
I would say so because think engines and systems, they're integrated now. Again, it used to be you worried about the engine and the transmission was some mechanical device, that was on the backside and you jammed 18 gears if you had a big truck. Now there's an automatic transmission for the truck. And if I can run the transmission at a certain, speed and characteristics it has, the engine, I'll run at a lot lower speed so that I get better. So now all of a sudden you have integrated engine and transmission systems, and you see, vertically integrated such as, Volvo and Freightliner, and you see PACCAR who has, there's an Eaton Cummins integrated system you can get, and you look at Navistar and others. So what's happened now is the whole system has become integrated, and so you have to be able to take the information and then it'll point you. You may think the problem's here, but it points you out that there was something else driving it way back in the back. So I think it's one of those you could have too much data. So what you've got to be able to do is, as I say, that's where you have a tool that allows you to take all of that and then simplify it into a form that someone can look at that it says, go here first.
You're listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and we've been speaking with Craig Barnes, president of Cab Consulting. We've been talking about the evolution of diesel engines. I'd really like to kind of find out, before we get into alternative, fuel sources and things like that, kind of wanted to get your opinion on where you see diesel engines going, let's say 5-10 years out.
There are the greenhouse gas regulations that were set up in 2018, set out requirements out through 2028. So the industry and the engine's a big part of it, but it's the entire truck. So and then they have you've heard of Super Truck 1 they did. Now they have Super Truck 2. So they're going to continue to develop those. The Super Truck programs are driving to make the engine more and more efficient and the whole system more efficient for fuel economy purposes. So old diesels that were in what we call brake thermal efficiency, which means how efficient the engine was, the high 30s and then the low 40% grew into the mid 40s, growing closer to 50. Super Truck had them testing that they could get to 55, and the Super Truck 2 goal is to get it to 60. So there's no slowing at continued development, and several companies have announced they're working on a new heavy duty platforms for the 22, 23 timeframes, which kind of get at the next round of greenhouse gases. So technology is going to continue around fuel economy and performance, and the after treatment side working with the engine. And that's, you asked earlier, that's another one I would say that integration has caused you to look at. Is my after treatment has problem, usually means there's something happening in the engine. Those two have to work together very closely and be optimized to meet standards that are going to continue to get more strict. You can't take particulate matter any further. I mean, it's at zero. So particulate filters, that's gone. Nitrous oxides are going to continue to try and drive them down, and they might California and New York and other states have talked about, and the EPA is working on a standard. So there'll be some further work there going on that'll continue to drive that down. So they're not going anywhere in that over the next 5 to 10 years. In fact, I'd be bold enough to say in certain applications, they really aren't going to go away in my lifetime and possibly even yours, because there's just places to where you really can't replace that power system with what it's doing. But people will continue. Now, the number of manufacturers, well, we've gone through cycles where those numbers have reduced down as people have joint ventures or they get together, that it becomes too expensive to develop those. And that's what you've seen, and maybe you'll see some of that, going forward. You've seen manufacturers have, done joint ventures or alliances together to do so you may see that. Navistar and Volkswagen would probably be a big look, where you're trying to help, because it is costly to develop these products, not just from the performance and the standards, but also then be able to do that over the life of the vehicle and over the rebuild life of the vehicle and over the next rebuild life of the vehicle. So it's very time consuming and to get there on those. And then also continued weight reduction. We probably started at 19 size liter engines way in the past. Then we got down to smaller, now the top end would be Cummins, around Volvo have 15, 16 liter platforms. You see a lot of 12s and 13s running out there on the open road. So you continue to drive lighter and more powerful, more power dense units so that you can carry more freight, which is the name of the game in the end.
Now, that's actually a good opportunity for us to kind of segue into electric trucks, because when you talk about the different kinds of trucks and you talk about where they're going to be best suited to use, and how maybe there will never be a time when we won't have a diesel engine used, at least in some areas or some sectors. When I think of electric trucks, I see right away the big problem is the charging cycles and the distances they have to travel. And, I think of in communities in Europe where things are so much more compact and the distances are so much smaller. And then you think of North America where it's just these huge, wide open spaces. You made an interesting point about electric trucks. What do you think the future of electric trucks are, at least in the next 10 or 15 years?
If you look, there's probably some niche areas where it makes a lot of sense right now. One big area that's being developed is around the ports. A lot of pollution there, and they want to work. So those don't have to have as much range, miles going on, and they're captive in an area. So if, recharging and those things, and they're zero emissions. So are there things there, and you see California's pushing that, major drivers in that going on. That's a really good one. Another good area is delivery. Okay, in the early, right now, batteries are still, their capacity, that's still the issue. Get enough capacity to go far enough for a very large vehicle. That's a lot of heavy batteries. That takes away from freight. Regional haul, and even below that, city delivery or those types of applications, a lot of packages delivered there. They're not heavy. So weight is not your issue. You can get the capacity you need. And also most of those go from a depot out, do their delivery. They know how many hours they're going to be out, and they come back. And in particular, I think there's a lot of, I'll call it warm weather areas, say the Southwest and California and maybe even Florida, where electric really makes sense, because there's still a lot of issues you have to sort out about cold weather. I may have this much range capability, and then it's 40 below zero, and all of a sudden I have a third of that range capability. So I think there are places that it will make sense there. Also, those chassis are probably easier to adapt. A strip chassis or something, you can put batteries where you want them. As I say, it's mostly package delivery. Electric is very quiet. So if I'm in an urban delivery area, a lot less noise. That would be very nice. And I can usually tell when the UPS guy's in my neighborhood. I can hear him coming. It may actually drive. The other thing is that you have to put a little noise in them so that they're there. So I think there are places to where it really makes sense. Long haul over spaces like you just mentioned. Yeah, how fast can you charge? So rapid charging is an important item for them to be able to set. Would you be able to convert a truck stop that when they pull in at night, and we tried this several years ago of, instead of a diesel sitting there and idling all night and running the hotel loads, we wanted to be able to have a plug-in device, and you could just that didn't work very, very well, but you could turn some truck stops into overnight charging things, but again, that's going to be how many are available and what you can do. So there's just a lot there going on. And then you mentioned service, and that those are another product different again from the next generation of traditional products. So you're going to have the right people that can work on them, readily available in a system. So I think summarize, there are areas that it makes perfect sense and would work well. I think in particular for heavy duty type applications, buses, city buses, transit, those are logical because they start and they stop, so braking can regenerate and recharge. I mean, they're just perfect for it. But driving down the road at 65 mile an hour, hauling a load somewhere, all you're doing is draining them. You're not putting anything back. So you just have to see where they go. And then off highway, again, it's going to be what are the applications that could be good at regenerating things. And you think of an excavator that does a dig cycle, swings a boom, dumps, swings back. That's a very nice potential application for electric.
Yeah, and I think when it comes to servicing these kind of emerging technologies, especially on the electric, I've often said, like, are we going to need electrical engineers to be able to maintain and service these things? It's definitely going to push heavy duty technicians. And maybe we'll talk about that a little more in a moment. One of the things that I often think about is this law of unintended consequences. So I think the motivation to bring the electrification of the industry is to try to make things better, to improve climate. But it's important, I think, that we continue to look at other technologies. And I've heard mention of hydrogen technology. What is the situation with the development of power sources that use a hydrogen source? I don't know a lot about it. Could you explain that for us?
Fuel cells were first invented in the 1830s, so it's not a brand new technology. And if you go back to the early 2000s in the United States, there was a big push by, I believe it was then President Bush, to have fuel cells in cars. And by 2020, we'd have production fuel cell powered cars, and companies got together and they formed, I believe it was called US Car. And that never got there because fuel cells basically require pressurized air pumped in and hydrogen, pure hydrogen. And they have to be technical for a moment, there's an anode and a cathode, and the hydrogen goes in by the anode and it takes forms positive ions and negative electrons, and those flow over a membrane and go to the cathode side where they combine and you generate electricity. And then out the other end comes water. Essentially the hydrogen that was used plus the oxygen come out, and they come out as water out the other end. So it is a clean combustion process. It's not a 100% efficient, but it is clean. And it's very good for pretty much, in my opinion, steady state operation, because it takes a little time to get this up to temperature, and most of the very efficient ones operate at very high temperatures. And so once they get up to temperature, you have this water that's coming out, but it could also be water vapor or steam because it's hot as it is. But then it sends the electricity, the electric that goes back, and then it can be used either directly to the motors that are driving wheels, or it can be used to charge batteries that are on board. And since most of these vehicles are, variable speed and load, batteries will be where you take the variation into the load going on, and the steady state will be the hydrogen coming in. And so there's there's been look at. I was actually involved at Cummins, and we were working on fuel cell projects and had government contracts in the early 2000s. At the same time, everything else was happening. Over the last few years, I mentioned ports and some of the other things there. Toyota has been working on fuel cells quite a bit. Hyundai has been. Toyota is partnering with PACCAR, both Kenworth and Peterbilt, on hydrogen fuel cell trucks in ports areas. Cummins even has shown a concept and has announced, they have a concept and has bought a company, Hydrogenics, to be in fuel cells, and is also working with Hyundai. And there's others that are looking at it. But probably the biggest name that's come out in probably the last 5-year window is Nikola Motor, which would be Trevor and his company out in Arizona now. And they're making a lot of big claims, and they're getting closer to production, and they're going to be a fuel cell truck. And what I look at in there, and most of us in the industry call them, the fuel cell is the range extender for an electric truck, battery powered truck. And they'll talk about what range do they have, which means when does the fuel cell use up the hydrogen and has to be refueled. And the goal is, refuel that within 10 to 15 minutes, which is like refueling a truck with, 150 to 300 gallon of diesel fuel, and be able to have that happen. Now, they've designed a truck from scratch that has all the other aerodynamics and other features in with it too. So they're probably the biggest noise right now. And in fact, I think it was just a couple of days ago they put out an announcement that they will show off a new battery technology that's supposed to be twice as dense. So they didn't start initially with hydrogen. They actually started with a natural gas idea and then quickly switched to hydrogen. So I think you're seeing a lot out there. It makes sense. I mean, it's very clean. It'll work again in some areas. The question now becomes, how do you get the hydrogen to refuel it? And again, as I talked earlier, if you've got out and back, you got some place you can do it. It will be a lot like natural gas vehicles were, if you're familiar with them. So you have to have high pressure storage and be able to do that. But they fit in with it. But they're in the electric truck realm. But those are really looking at the big Class 8s. You're not really seeing that technology moving into the medium duty trucks or the smaller, and pretty much the discussion about cars has disappeared. You don't hear that anymore.
So with all of these changes and all of this emerging technology, of course, it creates opportunity, but it also creates a measure of fear. I know, like myself, I'm 40. Anybody that's 20 to 40 years old, that's in heavy duty parts, let's say, that's in the repair business, we're asking ourselves, what is our careers going to look like in the future? And is there something we can be doing today to make ourselves employable 10, 15, 20 years out? What are your thoughts on that?
Well, I'd approach that in two-pronged. At first, I would say, even if these new technologies begin to come out, you know how many millions of trucks are out there today. And a new technology coming in is going to take 20 to 30 years to filter out the old technology. We found that particularly whenever we had new emission standards, we'd bring in new technology. And, it took a long time for that to become prevalent in the field. So, we could target technicians and capabilities needed, like particulate filter cleaning. Not every location had to have one of those initially. We could pick where they were. So I think, first of all, is the current technology and demographics and capabilities are not going to go away day after tomorrow. So you want to build it. But what you want to be able to do is, what are the next set of skills? But I look at a lot building on what you described earlier, the people who transition from mechanical to electronic to data. This is the next step. So yes, electrical engineers may be required to handle certain things, but they'll also be developing service tools that will guide you. The biggest thing I would say is safety. Those are the biggest trainings that you would need. Is again, if you remember, after treatment came in, those devices operated at 600, 700, 800 degrees C. So, don't touch anything. Or when it's in the shop, don't run it and let it regenerate. So, get to the temperatures. Well, in voltage, you're going to be talking 800 volts and those types of things. So safety is going to be important there. So a lot of training and knowledge about how to handle that, which is no different than the other types of things they did. And then, as I say, being able to use diagnostic tools and looking for opportunities. I mean, these systems are so smart that they have to give you guidance of where they're going. And we mentioned fuel cells a while ago. So you'll have a device generating electricity that goes into an inverter that then sends it somewhere, but then your batteries may also have to supplement it to get to the motors. But if you get inside a lot of these devices, an electric motor, 2-speed electric motor, you get inside of it, it's got gears and it's got castings around it. So, a lot of the, still going to have to be lubed and those types. So a lot of the trades and skills, and I'm going to say from parts, are going to be the same. What it amounts to is it's going to be this, I got to carry them both. So you may have to be able to do both is what's going to be, because I think it'll be a while before you just need an electric vehicle technician. You're going to need someone, but you're still going to have HVAC systems in the trucks. It's just they're electric now instead of before. You're going to have, pumps. You probably won't have as much, air brakes or those things. They'll go a little bit different, more to different types of technologies. But a lot of the same fundamentals are going to be is that they still have to roll down the highway. They have to still operate similar forms. So a lot of it's going to be there. The key will be comfort level at working with the systems.
Education is always the key. The more diverse you can be in the things that you learn, then the more valuable you are to someone and the more employment opportunities you have. Is that basically a good way of summing up what you just said?
That's a good way. I mean, being able to use your laptop, and be able to, pull it up and get information, that's what a lot of the tools are today. If you watch an engineer in the development of a vehicle or an engine, you always see them walking around carrying a laptop. The information comes in and then they get charts and graphs and all that stuff off of it. So, it's going to be, somewhere out in the future, like the fuel cells, that's a whole new area because, but it also may be like some other devices to where if that fails, they may say replace and send it back to be repaired, so they'll be in the early days, they'll be figuring out what can be serviced in the field and what needs to be sent back, which is a lot like after treatment was when it hit the field, right? You could do certain things, but others was, well, send it back and we'll send you, a different one. And the other area I think will come up a lot more will be reman, and remanufacturing and all of that. I think that has a big future going on also.
It's funny that you say that. When I started in the industry in 98, I started at a reman facility and we saw the remanufacturing of a lot of hard parts go away over the last 20 years. But it's so interesting to me how, what is new is just old recycled. These trends, they oscillate back and forth and the pendulum swings, far one way and then it comes back to center and then it goes the other way. And that just seems to be the way things go.
Right. Some of your technicians, as they come up in the future, may have a 3D part printer sitting in their shop that something breaks and they know who to call up and they can 3D print a part and put it back in the truck to replace it. Particularly as you're working, I think that could be a change for your technicians. As you get out in the field, service parts, aren't readily available. At John Deere, I spent a lot of time working with a gentleman whose job was to go find old John Deere tractors in a barn somewhere to get service parts for things that were, not available anymore. Now what they do is they say, I'll just 3D print it because, again, the requirements. So though there will be technologies, I think technicians and the parts people will be looking at that will be going. Also, I think you'll be looking at a lot more standards that some of these things across products are going to have to be pretty similar. It's going to be hard for them to have their own unique parts. And so it's going to be a little more vanilla in some cases how that works. But if you look in the cab and the operator station, and that's moving the way it's moving in the future.
Exciting times. You've been listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and we've been speaking with Craig Barnes, president of CAB Consulting. To connect with Craig, go to the show notes of this episode and click on the link. I've included a link to his LinkedIn profile, and you can connect with him there. Craig, thank you for being on the podcast.
Thank you, Jamie. It was my pleasure. Best and have a good day.
Have you subscribed to the podcast yet? Go to heavydutypartsreport.com to listen to and subscribe to the podcast. And remember to focus on cost per mile over purchase price. And let's keep those trucks and trailers rolling.